Hello, my name is Arthur Powell, and I'm a professor of mathematics education at Rutgers University in Newark, New Jersey. And I'm here to talk to you about the effects of the pandemic on research in mathematics education. And for this presentation, there will be three main topics: classroom-based research, teacher professional development, and the learning and teaching of rational numbers. It's a pleasure for me to be here virtually participating in the 8th SIPEM. And in particular, I want to thank the organizers, Maurício, Rosa, Marcelo Baihal, and others, for the invitation to participate in this roundtable. Today, I'd like to make some comments about COVID-19 pandemic and mathematics education research. In particular, I'd like to highlight some of the challenges and possibilities that I have experienced in the recent 2 years during the pandemic. So my agenda for this brief talk is to highlight pre-pandemic classroom and mathematics education research as I've experienced it, COVID-19 pandemic and social inequalities and inequities, and teaching and learning and research possibilities highlighted by the pandemic. So when we think about mathematics education generally, school mathematics in particular, we know that it thrives on face-to-face teaching spaces. We have students, we have teachers in classrooms, in schools or outside of schools, but interacting in person, in face-to-face environments. And this is particularly because the nature of mathematics is that it's an area of knowledge in which it has the capacity to compress information into abstract and highly usable forms, as Adler and Davis have suggested. So the idea of engaging in mathematics education in face-to-face environments is one in which it allows for the teacher to support students in coming to understand handed down school mathematics. And before the pandemic, it meant that collectively, learners in a classroom have been able to make sense of abstract mathematical concepts and phenomena, building on their experience. The important piece here is that they have engaged in this collectively. Many individuals in the same classroom. And the teacher's pre-pandemic role in the classroom has been to unpack and decompress mathematical knowledge for students by implementing different kinds of pedagogical strategies, such as problem solving, problem posing, or inquiry-based teaching, or problem-based teaching, using manipulatives, even using technology, and advocating for students to work collaboratively. And for researchers in the pre-pandemic era, mathematics education researchers would work inside of school buildings with teachers in order to co-design, to observe, and to assess teaching and learning in schools and in classrooms. So the entire milieu of our pre-pandemic existence as math education researchers has been face-to-face interactions in buildings, in classrooms, with teachers, with students, close up. The pandemic came, and all of a sudden, we had to cease entering into social spaces in which many people are engaged in some congregate setting, and we had to social distance. We had to be isolated from each other. And this meant that schools suddenly had to turn their paper-based assignments, they had to distribute these things to students so that students could work individually in their homes on the assignments. However, in many situations, in many school districts in the United States, and in particular in urban school districts, schools were without paper, or they didn't have a printer. Many schools, parents were unable to pick up the assignment packets because people didn't know how one could interact during the pandemic. Would it be safe for parents to go to a school building, even if the school building only had 1 or 2 people? Would it be safe for them to go there to pick up paper assignments? And when the pandemic first hit, we weren't sure if the virus, we knew that the virus was transmitted airborne, but we weren't sure whether or not the virus also was transmitted on surfaces. So if a school district had paper and had printers and could create assignment packets that could go home to students, it wasn't clear from the parents' perspective whether it was safe to pick up those paper packets. And then in many urban districts, in many poor neighborhoods, students were without space or organization in their home to manage working on the paper-based learning at home. And so these social inequities that existed pre-pandemic were exacerbated by the pandemic. But there were other ways in which the pandemic exacerbated social marginalization. We went from paper-based learning to online learning, where students had to be in front of a computer or a tablet or a phone, a smartphone. But many schools in urban districts, for example, were unable to provide each student with a laptop computer for use at home. Or there were school districts that did not have the equipment that they could loan to students. So students had to rely on whether or not their families had the technology at home so that they could go online. But in many situations, students did not have internet access at home. Or if they had internet access, it did not have wide bandwidth. It was slow. And there may be several individuals, several other students, other children in the home who also needed to use a computer to access their school online assignments, their school's online learning environment. And there was a competition in the home for use of the computer. So children with siblings at home and other individuals had difficulty establishing an adequate place to go online. So this situation of turning schooling from going to an institution to being at home and relying on online internet access exacerbated social marginalizations, social inequities. There are many situations in which students in urban districts were simply absent from participating in their classroom online because they didn't have the resources, or there was an older sibling at home who needed to get online, or a younger sibling at home who needed to get online. Another way in which these problems were exacerbated is the use of the technology. Many parents did not have facility with online learning environments and were unable to help their child, particularly younger child, get online, know how to navigate the online system. But there were also problems for teachers and for doing professional development in classrooms. So the kind of research that I do is research in which I work with teachers, in-service teachers, and I work in classrooms. And so my research involves teacher professional development and classroom-based research, where the work in the classroom is with the assistance of a teacher. All of these activities were forced online. And of course, the challenges of internet access and speed existed, meaning that even the teachers themselves sometimes did not have the conditions that allowed them to offer online instructions on a consistent and uninterrupted basis. But then teachers had to learn how to not only use the hardware, but they had to now research and be trained on different software applications. And this presented a number of challenges for them. For example, we know that software applications modify the representation of mathematical objects and relations and the dynamics that exist among those relations. And so now teachers had to think about how were the mathematical ideas that they were teaching going to be represented in this online environment? How were the mathematical objects, which are now dynamic, were going to be represented in ways that they understood and in ways that they could create lessons and tasks for students that would be adequate for the use of the software application and for the particular mathematical ideas that they wanted to teach. So the use of the hardware and software meant that there was an increased cognitive load for teachers, for students, and for researchers. But there were interesting ways in which using what Gattegno calls powers of the mind, we could meet the challenges of the pandemic online environment. First of all, Caleb Gattegno studied early language acquisition of children. And in his study, he classified several different, what he called powers of the mind, which were evident among children as they were acquiring facility in their native language. And here are two references for the studies and his reports on his findings. But let me just say that for Gattegno, there were several powers of the mind that he classified, but there were four very important powers of the mind that I think we could use, and I'm going to give evidence of its use for meeting challenges of the pandemic, for mathematics education, teaching, and for research. The first power of the mind that he identified is what we call the power to extract. That is, to find what is common among so large a range of variations. So as children are learning to speak their mother's tongue, they use their minds in order to extract what's common among, say, the various ways in which they hear words or a particular word. So each individual from which they hear that word spoken, that person has a different tone, has a different voice, but they extract from all of the variation what are the essential elements that allow them to use their articulatory system to reproduce the sound, to reproduce the concatenation of sounds for saying a word. So, a power of the mind that we can rely on is the power to extract, that is, to find what's common among a variation. Another power of the mind is to make transformations. Before children enter school, they have evidenced their ability to understand that, for instance, the phrase, my daddy, is equivalent to my mother's partner. And it's equivalent to my sister's dad. And that's equivalent to my uncle's brother. So my dad can be thought of and spoken about in these different ways. The same object, the same idea can be spoken about in various ways. And these transformations the child copes with and learns to understand the equivalencies among these different expressions of ways of describing an object in the world, my dad. Another power of the mind is to handle abstractions. That is, any noun is a label for a general set of objects. So the word chair, we know that when the child is taught the word chair and is shown a chair, they eventually understand that that word stands for not only that particular chair that they were shown, but other objects in the environment in which people use, for which people use to sit on. And so they may call a couch a chair, and over time understand that the word chair is isolated for certain kinds of objects which are different than couch, even though the function can be considered the same. And so, a noun is a label for a general set of objects, is an idea which Gattegno called for as a power of the mind abstraction. And then the fourth power of the mind that I want to highlight here is what he calls stress and ignore. That is, the ability to focus on one aspect of something that you might be looking at or perceiving, and to exclude or ignore other aspects of that thing. So the child recognizes a parent irrespective of the clothing that the parent might be wearing. So the child stresses certain attributes of that individual while ignoring other attributes of the individual in order to recognize, that person is my sister, even though today she's wearing clothing which were different than the day before. There are other characteristics of that individual that I recognize and that I can stress and ignore other things. And so these four powers of the mind are ones that we can rely on and develop tasks, develop mathematical tasks, which call on students to exercise these powers of the mind. And these tasks can be in online environments where the design of the task is such that it relies on individuals using these powers of the mind in order to meet the challenge of the task. So what's an example of that? Well, this particular picture is taken from an online environment which simulates a geoboard, but can be imagined to be in other kinds of situations. Where here, one is asking for individuals to make other four square shapes. So here we have two shapes. The claim is that each of these two shapes is composed of four squares. And students working together in an environment, in a virtual environment, can engage in a conversation about whether the shape on the right is really a four square shape. The shape on the left probably more easily can be seen to be a four square shape. But the one on the right requires students to use their power of transformation and stress and ignore in order to see that indeed that figure is composed of four squares, where two of the squares have been decomposed in such a way to create the outline of the shape. By working on and asking students to make other four square shapes, over time, they will begin to understand and be able to articulate for themselves what we call Pick's theorem for finding the area of shapes on a grid. Another possibility is to use an online environment that we call virtual math teams, VMT, which not only provides the possibility of having a figure displayed on the screen, but the figure can also be moved. It can exist dynamically on the computer screen or the tablet screen. And moreover, it makes available the possibility for individuals in the same room, virtual room, to engage in conversation through sending messages to each other, chatting, so that any message that an individual sends is simultaneously seen by all other members who are in the same chat room. And they can work collaboratively on solving and posing mathematical problems. So open-ended problem solving as well as problem posing can be engaged in this environment. And the environment is one in which you can have classes of students working in small groups in different online rooms in order to engage in discourse around developing their mathematical ideas, their mathematical reasoning. And so these are ways in which, and what I want to point out here is that the powers of the mind that Gattegno identified are designed the tasks are designed to engage students' powers of the mind, where they use their powers of the mind, where, for instance, in this particular task, they're looking at these pairs of rectangles, colored rectangles, in order to determine in what way are they similar? In what way are they equivalent? What relationship do the pairs have to each other? And through their discourse and chatting about these objects and moving the objects around, they will come to understand that they have equivalent ratios. And this can be a way of helping them develop the idea of equivalent fractions or equivalent ratios. So the pandemic has actually brought to us, opened up new possibilities. These possibilities existed pre-pandemic, but now during the pandemic, since we have to work online, it allows us to engage learners in collaborative settings so that they, through the exercising of their powers of the mind, can develop powerful mathematical ideas. There are many questions for research, such as, how is it that youngsters engaged in these environments develop collaborative norms? How do they monitor their collaborative norms? And in what way do groups that have powerful collaborative norms, what kinds of mathematical ideas do they develop? And what are the ways in which the collaborative norm shapes their development of their mathematical ideas? If we can understand that deeper than we currently do, we can further improve the design of mathematical tasks that can be offered to students in order to engage them in the development of their mathematical ideas and reasoning so that they can become agents of their own learning and develop the mathematical powers that we know that we would like for them to develop into. Thank you very much for your attention. I look forward to our discussion.